Section 1.3 is going to be all about operations with fractions. Now you will see that in your reading, you will read about converting units as well, which is a very good topic to read about, but we're not going to focus on that topic in the homework and in this lecture video. Okay, so it's all right if you read about it, but don't be worried that you're not going to see it in the video or in your homework. You also won't see it on your tests or quizzes for this class. Okay. We're just going to talk about operations with fractions, and converting units is just kind of an application of operations with fractions. All right, we're going to look at other applications, just we're going to kind of skip over that particular application for this particular course. Okay, so a fraction. We've looked at these when we've looked at division in the last section. Because a fraction is just division between two variables. We just sum that up into a fraction. So let's get that down so we remember that. A fraction has the form A over B, meaning A divided by B, but it will always be in this form. That's a fraction when you're looking at division in that form. And we reviewed this a little bit last time too, but always remember that A, the number in the top of the fraction, is called the numerator. We'll see that word used a lot today and in this section. And B, the number in the bottom, is the denominator. So couple things, couple different terms to remember when looking at fractions, okay? One very big note to remember is that anytime you divide, you cannot divide by 0. So a big note here is to always remember that the denominator, very specifically the number in the bottom, cannot be 0 when we're looking at a fraction. It is not possible to divide something among 0 people. Now it is possible for the numerator to be 0. I can take nothing. I can take 0 pies and divide it among 4 people. That just means everybody gets 0 pies. But there's no way to take 4 pies and divide it among no one. Nothing happens. So that's kind of the way I like to remember it. But what you really need to remember here is that you cannot divide by 0. Your calculator will also always remind you of that. So if you try to divide by 0 in your calculator, you'll always come up with an error, okay? So what we want to talk about today is how to carry out operations with fractions, because this is kind of our hardest operations to carry out by hand. And I do want you to try and carry these out by hand. So the homework does do a really good job of telling you, hey, this one, don't try and do it by hand, plug it into your calculator. And it is really important to learn how to do this in your calculator as well. But the simpler ones, I want you to be able to do by hand, and I will be looking for you to show that work on any exam that you hand in. If I say, hey, divide this, multiply this by hand, and show me your steps, I'm going to be looking for that work so I know that you understand what's going on when carrying out that operation. Okay, so as you're doing the homework, if it doesn't say do this in a calculator, do it by hand, maybe check it with your calculator to make sure you did it correctly. Use that calculator, you have it, but always make sure you can show that work so you show that you understand how these operations are carried out. All right, so with that being said, let's look at how do we multiply fractions. So multiplying fractions. Now I will say we're going to go through just a few examples of each operation. So I'm doing this to kind of jog your memory back to how to do this. We're assuming that you're coming into this class learning this before, having learned this before, but that we're just kind of jogging your memory back to it. Okay, so this is going to be a fairly quick review overall. If you need more help with it, then make sure you're letting me know so that I can get you the resources to get you more help with these topics. Okay, this first chapter is just very quick review of some different topics. So what we want to remember is that in order to multiply fractions, so if I have a fraction A over B, and I want to multiply it by another fraction, let's call it C over D, then multiplying is kind of our favorite operation with fractions, the easiest one, because we get to do kind of what we want to do. We get to just multiply across the top, and multiply across the bottom in order to carry out that multiplication. Okay, so let's just give this a shot. Let's look at an example really quick of how to find the product of two fractions. So if I look at an example, can you take 1/3 times 2/5? So just like that operation up there says, what you're going to do in order to carry this out is just multiply across the top and multiply across the bottom. 1 times 2 is 2, and 3 times 5 is 15. So my final answer when I take 1/3 times 2/5 is that I get 2/15. Now before we do too many more examples with multiplying fractions, that particular one was set up very specifically so that there was no simplifying that had to be done. Whenever we're doing operations with fractions, we need to make sure we have our result in the most simplified form. So this is in the most simplified form because 2 and 15 don't have any common factors. Numbers that have common factors are numbers like 2 and 4. 2 and 4 have a common factor of 2. Okay, so what happens if it isn't in simplest form? Well, how do we simplify fractions? So we're going to jump to kind of a side topic really quick, and then we're going to come back and look at some more multiplying. So simplifying fractions, how does this go? What does it mean again before we continue with some more examples of multiplying? So what this means is if I have two things multiplied together in the top of a fraction and two things multiplied together in the bottom of a fraction, but those have something in common. So here we're seeing that A in common here, that's a common factor, and that can cancel. So the A's can cancel, and this whole fraction simplifies to just B over C. So let's look at an example because that'll make more sense. So our example here is that we want to simplify, and we're always gonna want to get fractions in the most simplified form so then that they're in a unique form. We're going to simplify 18 over 30. Now what this means is I need to think about, okay, what can I divide 18 by? What can I divide 30 by? What's the biggest thing in common that I can divide both of them by and make this the most simplified fraction? Now, you don't have to find that biggest thing right off the bat. Like maybe here, so I'm going to do this in a couple of different ways. Maybe here the first thing you realize is that both of these numbers are even, so both of them can be divided by 2. So break that 2 out. Write it out. 18 is 2 times 9. And 30 is 2 times 15. So the 2's can cancel, but what you always want to make sure of is that the fraction you have left is also simplified. So think about 9 and 15. Can those both be divided by the same number, or is that completely simplified? And those can both be divided by 3, right? Because 9 is 3 times 3, and 15 is 3 times 5. So there's actually 3's that will cancel as well. And our final most simplified fraction is that 18/30 becomes 3/5. So you can do it in a few steps if you happen to see a smaller factor first and you didn't see the bigger factor. The way to make that a little bit quicker is if you realized that since 2 and 3 are both factors, that means 6 is both a factor. So 6 times 3 and 6 times 5 is how 18 and 30 can break down. The 6's can cancel all at once to get us down to the same most simplified fraction. So this one was a little bit more work, right? But we had to think about this number and make sure we got it. So either way, whatever works best for you, just make sure when you get done, you know it's in the most simplified form. 3 and 5 have no common factors, so that's our final answer. Always make sure you have the most simplified form. Okay, so let's do a few more multiplying. Let's go back to some multiplication examples. Okay. and make sure that our final answer is always in the most simplified form. So let's do some more examples. This time we're not just going to find the product, we're going to find the product and simplify. Okay, so first one here, can you take 2/3 times 5/6 and get the most simplified answer? Now I would always take that step to combine these first. That's 2 times 5 over 3 times 6. But be a little bit careful here. I wouldn't go ahead and multiply yet because we already have the numbers broken down. So it's a little bit easier to see common factors before you multiply rather than after. So this is where I start to think about the top. I say, okay, I see a 2. Is there a factor of 2 and 3? Nope. Is there a factor of 2 and 6? And there is, right? 6 can be divided by 2. So if I think about this, I can break it down a little further. This is 2 times 5 over 3 times, and if I take the 2 out of 6, I get 2 times 3, right? Because 2 times 3 is 6. Okay, so I break that 2 out, and then once I break it out, I can cancel it. So I'm going to go ahead and cancel that 2, and I'm going to look at my numerator again. I see a 5 this time. Is there a factor of 5 in 3? Nope. Is there a factor of 5 in this 3? Nope. So that means there's no more common factors, and once I know that for sure, then I'm going to go ahead and carry out my multiplication. Once this is canceled, it becomes a 1. Okay, so you can think about it not being there or it being a 1, because 2 divided by 2 is 1. So 1 times 5 is 5, over 3 times 1 times 3, so that's just 3 times 3, which is 9. 5 and 9, I can do one last double check. 5 and 9 do not have any common factors, so that's the most simplified version, and my final answer after taking 2/3 times 5/6. And this is what I mean by showing work. So I would want to see all of this work here on an exam if I asked you to do it by hand. Okay, now you could absolutely pull out your calculator and say, hey, did I get that right? And make sure you can do these operations in your calculator. So grab your calculator right now, make sure you can take 2/3 times 5/6 in your calculator and get the correct answer. If you're struggling with using your calculator with fractions, because it can be tricky, make sure you ask me in class. I'm going to make sure in this section that I go around and make sure each of you know how to use that, okay? Because it is a very powerful tool we want to use, but we do want to know what is the calculator doing in order to get these answers. All right. Can you take 8/10 times 20/64? Okay, so again, I'm going to suggest for your first step, just go ahead and put those things together, but don't actually multiply out yet, because again, you already are looking at broken down factors, and that's a little bit easier. So I'm going to start with the 8, and I'm going to say, okay, can 10 be divided by 8? Nope. Can 64 be divided by 8? Yes. So one kind of quick thing you can do instead of writing that out as well is say, okay, 8 can cancel from both 8 and 64. 8 divided by 8 is 1, and 64 divided by 8 is 8. Okay, so now what I'm looking at is 20 times 1 over 10 times 8. And now again, before I actually carry out that multiplication, I want to think again. Do 20 and 10 have any common factors? And they do, right? They can both be divided by 10. So again, I want to think, okay, 10 divided by 10 is 1. 20 divided by 10 is 2. So now I have 2 over 8. Is that the most simplified answer, or is there something that both of those can be divided by? And those can both be divided by 2. 2 divided by 2 is 1. 8 divided by 2 is 4. So my very final answer, when I'm all done and there's no more common factors is 1/4. Okay, so sometimes it takes a few steps. Just keep asking yourself that question. Can any of these numbers in the top be divided by the same number as something in the bottom? All right, on this one, I would suggest pausing the video, seeing if you can do it and get the right answer. So can you take 21/11 and multiply it by 33/7? All right, so did you set that up first? So I have 21 times 33 over 11 times 7. And the first thing I'm going to look at is, do 21 and 11 have any common factors? They don't, but 21 and 7 do. 21 and 7 can both be divided by 7. 7 divided by 7 is 1. 21 divided by 7 is 3. You might also be able to tell in this same step that 33 and 11 have a common factor of 11. So 11 divided by 11 is 1. 33 divided by 11 is 3. So now I've got a 3 times 3 in my numerator, which is 9, and a 1 times 1 in my denominator, which is 1. And anytime I have a number divided by 1, that can be simplified to just the numerator. 9 divided by 1 is 9. Okay, so you'll kind of come up with your own tricks as you do this too, but again, you're just trying to find those common factors. All right, that's kind of your most simple operation with fractions, which is kind of funny because multiplication is kind of one of your harder ones with normal operations, right? Division actually becomes kind of the second easiest operation with fractions, mostly because it's very similar to multiplication. There's just one extra step. So division with fractions, or dividing fractions, however you want to say that. Okay? Here is why it's easier. If you have one fraction divided by another, it is the same thing as the multiplication problem with the second fraction flipped. So this is the same thing as taking A divided by B, or A over B, and not dividing it anymore. So your operation is going to change from division to multiplication, and your second fraction always flips. So you always flip the second fraction. The first fraction will always stay the same. So A over B divided by C over D is the same thing as taking A over B times D over C. And we already know how to do this operation, so we just have to remember that first step of flipping the fraction. So we're just going to do a couple quick examples of this, because we've mostly done this problem. We just have to remember the first step. So your first example here, can you take 5/8 divided by 1/3? So your very first step should be to switch this to the multiplication problem. So 5/8 times 3 over 1. We flip the second fraction. Now this is the same steps as we did before. We know how to take 5/8 times 3 over 1 now. First, we'll write 5 times 3 over 8 times 1 and look for any common factors. Now in this one, there are no common factors. 8 and 5 cannot be divided by the same thing, and neither can 3 and 8. So we just carry out the multiplication. Our final answer is 15 over 8. Okay, try this one. This one would be a good one to pause, see if you get the right answer. Okay, can you take 7/12 divided by 14/3? So did you do that first step? Did you do 7/12 times 3 over 14? Did you set that up as your full multiplication problem without actually multiplying yet so you could find common factors if there are any? Did you figure out that 7 and 14 both have a 7? So that simplifies there. And did you figure out that 3 and 12 both have a 3? So that simplifies there. to get to your final answer, 1 times 1, which is 1, over 4 times 2, which is 8, for a final answer of 1/8. There you go. All right, so once we know how to multiply fractions and we remember that first step for dividing to change it to a multiplication problem, we're good to go. Now, the next operations are your harder ones because you have to get that common denominator. Hopefully that kind of triggers something in your brain, remembering a common denominator. So adding and subtracting fractions. Now these operations are very similar because they both need that common denominator. So we're going to put these two together in the same topic. Okay, so the deal with fractions and adding and subtracting, is that if we have one fraction plus another fraction, those denominators have to be the same. And if the denominators are the same, then I can just add the numerators over that common denominator. And the same thing is true with subtraction. It's just that then you will subtract the numerators and that will be over the common denominator. Okay, so here's what I mean. We can take 6/13 and add 2/13 to that. This is your easiest type of addition with fractions because you already have a common denominator. That denominator, when I'm adding and subtracting fractions, is kind of like a common unit. I can take 3 apples and add 2 apples and know that I have 5 total apples. So if I have 6/13 and I add 2/13, then I have 6 plus 2 of that common denominator of 13. I have 8/13. Now here you have to carry out that addition and then you can simplify your final answer if there is something to simplify. Here 8/13 is completely simplified. If instead here I was taking 6/13 minus 2/13, all that changes is the operation in my numerator. It still is the same idea. It's just that I need to subtract the numerators. 6 minus 2 is 4/13. I have 6/13 and I take away 2 of them, so in the end I have 4/13. Already simplified, so I'm done. Now the hard part here is when you have to add or subtract fractions that don't already have a common denominator. So what if I have 1/3 plus 5/9? Then I have a problem. I can't just do what I did with multiplying and add 1 plus 5 and 3 plus 9, right? Because what I need in order to add these is a common denominator. Think of that kind of like a common unit. Okay? So the way we're going to do this is to get the denominators to look the same by multiplying. So we look at the denominators and we say, can I get 3 to be 9 or 9 to be 3 by multiplying? And the answer here is that you can get 3 to be 9 by multiplying it by 3. So 3 times 3 would make that fraction have a denominator of 9. But the problem is I can't just multiply this fraction by 1/3, it would change it. Well, when I multiply a number by 1, it doesn't change, right? So what I'm going to do is multiply both the numerator and the denominator by that 3 to get the common denominator. So now my problem is 3 times 1 over 3 times 3. 1/3 is the same thing as 3/9. If you were to simplify 3/9, you would get 1/3. So I'm just changing that fraction by multiplying it by essentially a fancy version of 1 to get it to have a common denominator with my other fraction. Okay, and I was able to do that because, oops, wrong color, because 3 and 9, 3 could be turned into 9 by multiplying it. Now that I have that common denominator, I'm good to go. 3/9 plus 5/9 is 3 plus 5 over 9, which is 8/9, and that's already simplified. So that's where I'm done. Now, it can get just slightly more complicated when we have something like 5, 6 minus 4 sevenths. Because I can't turn 6 into 7, and I can't turn 7 into 6. So what I'm going to have to do is multiply them both by a number to get to a common number. We often call that the least common denominator. In this particular case, the least common denominator would be 42. I need to take 6 times 7, and I need to take 7 times 6. When I do that, I get a common denominator. 7 times 6 is the same thing as 7 times 6, right? So you get that common denominator. So my first fraction becomes 7 times 5, which is 35 over 42. And then I will subtract 6 times 4, which is 24, over 7 times 6, which is again 42. So that is now something I can subtract. That's 35 minus 24 over that common denominator. 35 minus 24 is 11 over 42. There's no common factors there, so we're done. All right, so you have to do that trick of multiplying by fancy versions of 1 to one fraction or possibly both fractions in order to carry out addition and subtraction. So again, all of this work is what I would want to see if I said, hey, do this operation by hand. But 100% you can check these things in your calculator to make sure you got the right answer. And if we have really big fractions or ones that aren't easy to do some of that mental math with, then in that case, like your homework will say, hey, just do this in your calculator. Make sure you can use your calculator for these operations, which is again very important. So again, try all these with your calculator, make sure you get the same answer. And if you're struggling with that calculator, make sure you're reaching out to me or asking me in class as to how to use your calculator. Okay? The last thing we want to do in this section, so feel free to pause if you kind of need a little bit of a 5-minute break here. But the last thing we're going to do is just a couple application problems. You're going to see some more application problems in your homework as well. So I just want to go through a couple of those with you. All right, so let's look at some application problems when doing operations with fractions. The first one I want to look at, we're going to see if a student completes 9/13 of an assignment. So thinking about what that would mean, right, to complete 9/13 of your assignment, that would mean like if there was 13 questions on your assignment, you've completed 9 of them so far. Okay, kind of that idea. Then can you tell me what fraction or proportion, you'll see both of those words as you are reading, they mean the same thing. Okay, proportion just means the portion of 1. What fraction or proportion is not complete? So how would we figure this out? What's going on here? We've completed 9/13 of an assignment and we want to figure out what proportion is not complete. So think about here, what would be the whole assignment? Because what we need to do is take 9/13 away from the whole assignment. So you're taking something away from a whole we always think about the whole thing as being 1. Okay, so we want to take the whole assignment here minus what we've already completed, and then that will give us what we haven't completed yet. Another way to think about this, right, is if I completed 9 of my 13 questions, how many questions did I start with? How do I get a common denominator here? Well, I change that 1 into terms of 13s. 1 is the same thing as 13 divided by 13. So I had 13 questions to start with, 13/13 of my assignment, and I completed 9/13 of it. That means I took 13 questions minus 9 out of the total 13 questions. I have 4/13 or 4 of the 13 questions left to complete. So the proportion that's not complete is 4/13. Okay, so anytime we're thinking about what's left of the whole, that we're taking the whole minus what we know to get the rest. So a good way to visualize this is in this next application. So in this one, we're going to look at the proportions of a disk. Okay, so the proportions of a disk are going to be shown. We're going to draw it here in a second. And once you look at this, I want you to find the missing proportion, which is kind of what we just did, but without the visual. Oops, let's make that 2 different words there. Okay, I want you to find the missing proportion. So here we're going to have a disk. Okay, I'm going to draw a circle the best I can. That's fairly good. Okay, here's what we know. It's broken up like this. This is 1/4 of the disk. This is 1/5 of the disk. And I want you to find the remaining proportion. Okay, so again, think about the whole disk is 1, right? We often represent proportions by thinking about a whole circle, and the whole circle itself is 1. So in order to solve this, we need to take the whole disk, and we want to just find this area, right? So we want to take out 1/4 of the disk and then 1/5 of the disk. So we want to take the whole disk minus 1/4, and then we want to subtract the 1/5 again. So let's first take out the 1/4. So how are we going to solve this problem? Very similar to the way we just solved the last problem, right? 1 we can think about as the same denominator. 1 is 4/4. We're going to take 4/4 minus 1/4, and that leaves us with 3/4 of the disk. So that would be all of this. But that's not what we want, right? We don't want all of that area. We want to take out that 1/5 as well. So now we're left with 3/4, and we need to take 1/5 away from that as well. So 3/4 then minus that last 1/5, and we need to complete this next problem to get the final answer. In order to complete this, we're going to need a common denominator. That least common denominator would be 20, so we need to take 3/4 times 5/5 and 1/5 times 4/4. That'll give us 15/20 minus 4/20. And then we've got kind of an easy problem, or the easiest part of the problem left, which is just to subtract the numerators. And we find out that that last remaining proportion, so this proportion right here, would be 11/20 of the disk. All right, so think about a whole and subtract what you know to get what's left. Okay, and a good trick is to always write that single 1 in terms of the denominator of whatever you're trying to subtract away. All right, so that should hopefully set you up well to try out the homework, and reach out to me if you have any questions. Thanks, guys.